This video, we will see the application of exponential function as a growth function. Okay, so we are saying it growth because here we are writing e power rt. Okay, so exponential growth function is represented by p of t, p which is a function of t equal p naught e power rt. This is one form. Some represent it in this form as well, like a equal p e power rt. Now, what does this a, p, r, and t represents? So, p represents the initial value. Like if we want to know what will be the population of one place after, say, 10 years. So, first we should know the initial population. So that is what represented by P, the initial value we see in journal. Okay, then R means the rate of growth or rate of increase. And T stands for time. Generally, it is number of years, days, or weeks. Okay, then after knowing all these things, like what is the initial population, at what rate it is growing, and for how long we want to know, like in how many years we want to know the final. So A gives you the final population, or you can say the final. So if you know all these things, you can easily able to solve the questions based on the exponential function. So let's consider some example. So what it says, the population which is denoted by A of a colony of insects up P days after the commencement of an experiment is given by the exponential law a equal e to 20,000 e power 0.003 times t. So this is the function which is given, which represents the growth in the population of a insects in a colony. Okay, so based on this you have to find what is initial population, then what is the population of insects after 10 days, and the number of days for the population to become 40,000. So for that, what we will do, we will compare our A with the standard equation of exponential growth function. Okay, so let's write it down. What we have, A equal P e power RP. If we compare, what we can see, in place of P, we have 20,000. T is same. In place of R, we have 0.03 T. Okay. So, what we will get here, let's write down what we are getting. P, that is the initial population, is 20,000. R is 0.03. Now, you don't know the final value, the final population. You don't know, and also you don't know the time. Okay, so P and R, the initial population is known, initial value which is P is known, and the rate at which it is growing is also given. So let's see how we answer this parts. They ask, find the following initial population of the insects. Initial population. So yes, initial population is here. So here the answer will be 20,000. Okay. Then in part B, they ask population of the insects after 10 days. 10 days. In days, we represent time. So this is your t. So in this equation, now they give you time. T equal 10. You have to find what will be the population. So let's see how we do it. So you have P equal 20,000. Let's write our equation which is given. 0.03 times t. Okay, here. So what is here? T is 10. So replace here t by 10. T is equal to 10. So change here t by 10. This gives you 20,000 times e power 0.03 multiply 10, which is nothing but 20,000. Sorry, I missed one zero here. And e power, if you multiply 0.03 with 10, you will get 0.3. At this stage, you use calculator to get the final answer. So once you work with calculator, you get the value as 26997.176. So this is the population after 10 days. So this is answer for R. Let's go to the next question. They say number of days for population to become 40,000. Means you need to find number of days. It means you need to find how long will it take for the population to become 40,000. Means this is your final population. Okay, final population means A. So in this example, A is given to be 40,000 and you have to find T. Did you understand the difference between B and C? In B, T is given to you 10 days and they ask you to find the population, final population. Whereas here, the final population is given to you. They ask you how long it's going to take. Okay, so let's solve it. So we take the main equation, okay, where A is given to you and we have to find T. In the previous part, the final population was A, not B. Okay, just correct. Okay, so here, now substitute 40,000 equal 20,000 e to the power 0.03 t. So you have to find t. So it is like any exponential equation. Okay. So when you solve it, what you will do first, since you have to find t, you divide both sides by 20,000. Okay. It's just a process of simplification. So these two cancel. What you left here? Cancelling all zeros, 4 divided 2 gives you 2. E.03t. Okay, now what we do in such questions, we take ln of both sides. So this gives you ln of 2 equal ln of e to the power 0.03t. Using the rule of exponential, this power comes into here. Ln of e is nothing but 1, so it will be 0.03t ln of e and here ln of 2. When you simplify it, what you will get? Ln of 2, you can simply calculate by using calculator. It gives you value 0.6931 equal 0.03 times t. Nothing means multiplication. Ln of e value is, now since you want p, you divide it by 0.03. So what happened? It cancels, giving you only t on the right hand side, and then when you divide the left hand side, you get here 23.10. So this gives you the value of t. So it take like t equal to 23.10 days for the population to reach 40,000. Okay.